Okay. So apparently it's time to start. My project title here, Opening Up the Classroom, Teaching GIS with Open Source Tools. And this is who I am. I'm Jessica Breen. I'm a PhD candidate in the Department of Geography at the University of Kentucky, which is in Lexington, not Louisville, for those who are confused about that. These are the organizations that I work with within the university. I'm a fellow with the New Maps Collaboratory. That will be important later. And I'm also the research assistant for a program called Map Shop, which is a community-oriented mapping cartographic studio that we run sort of as an outreach program within the geography department. So I make a lot of community maps. And here's my email address and Twitter if you're into that sort of thing. All right, so I'm going to tell you a little bit about the course in GIS that I have taught for a couple semesters now, and the process of switching that over from being a traditional intro GIS course where you teach ARC to opening up to more open source tools, primarily QGIS. So when I first got asked to teach my own GIS course, I was really excited about this. GIS is probably the reason that I'm a geography student and not like an anthropologist or a sociologist. The whole mapping and spatial aspect of geography was really appealing to me, so getting the opportunity to teach my own course and get to fix some of the things that I had seen as a TA, I was really excited about. So I had been teaching geography GIS labs for a few years, but to teach my own course was really exciting. So I spent a lot of time working on it. This is the generic course description that all of intro GIS courses, we have 2 a semester. This is the course description that we have for each of them. And you can see it's pretty generic. We introduce students to the use of geographic information systems and basic principles. We cover data collection, processing and output, different types of geographic information and data sources, constraints and uses, some of the secondary stuff that's available, and then the collection of primary spatial data using GPS and other technologies. You'll notice that there is absolutely no mention of software in this. So conceivably, you could teach this course without any software. No one has ever actually tried to do that, but technically speaking, you could. So again, the fact that this is software agnostic, again, becomes important later. When I got to pick up my own textbooks, because there's no requirement that the 2, every semester, the 2 different sessions of the course, they don't have to match. They're taught independently. So I chose, these were my 2 textbooks. I think I was actually using the 4th edition of Bolstad's GIS Fundamentals, but I couldn't find a picture of that one. They're very similar, as I understand. But that's another software agnostic GIS manual. That's actually the one that I used as an undergrad taking GIS courses. It's been updated a few times since then, but it's very straightforward, but it is completely agnostic. So it doesn't have to change with an updated version of the software. So you don't have to worry about midway through the course that something's changed and you have to explain every time you talk about that object that it's changed from the book. It's always good. And then because I really hate grading ugly maps, I have the Making Maps visual guide for map design and GIS from Krieger and Wood, in the hopes that students would actually take a hint and not use the generic, ArcGIS colors for things and give me retinal damage from bright orange maps. The other great thing about this particular textbook is it too is agnostic software-wise. It also is highly graphical, which makes sense for a book about teaching maps. But it's just a lot more pictures than text. So students actually get to learn about which color schemes to use based on seeing it more than being explained color theory to them. And then the next part here, just sort of how my course worked. It was Monday, Wednesday, Friday. They're only 50 minutes. This is kind of a weird GIS course in that it's not technically a laboratory course. We get 3 lecture sessions. And within that, you're supposed to manage to find a way to teach a lab. So the way that I would do it, on Mondays I had lecture, and that was about whatever the topic was for the week. Wednesdays we went through course readings. Those were separate from the Bolstad book. Those were usually things that were more topical, news, things that were going on currently. A lot of, we're a critical mapping department, so there was a lot of Harley and Krieger, Crampton in there. And then we would go over the lab for the week. So I would make sure to show them, these are the potential pitfalls that you might come to, but we just walk through it. And then on Friday, they had their chance to be in class with me and the computers to actually get through the lab. And then the next Wednesday, the lab is due. Also within this course, we have, so that's the first 10 to 12 weeks of class, we do it that way. And then the last part of the class, last 4 weeks, it's projects. So the students are able to, having gone through basic GIS manipulations, they're able to pick their own project. They have to find their own data, they make their own map, they sort of set it up themselves using all the tools we've used in the semester. They have to come up with their own project. Sometimes I've done this with groups, sometimes individuals. It depends on how many people are in the class. To varying effects, groups work versus students by themselves. So why switch to open source? This is the big question, and the answer is basically access. It's all about access. The University of Kentucky is not a GIS powerhouse. We have a 24-seat GIS lab. We run 2 sections of GIS, so only 48 GIS students a semester are taught. It's not a lot of access to the computers. Our lab was only open from 9 a.m. until 4 p.m. And there were classes going on in that space during that time. So students didn't have a whole lot of access to our resources in the department. They did have access to the library. The library has ArcGIS, and it's open 24 hours. But there's no one in the library labs who knows anything about using ArcGIS. So the students who couldn't make it back to the department GIS lab to actually use the computers when they needed to do work, they'd go to the library, they'd get stuck, and there's no one to help them because the library techs are other student workers and they don't know how to use Arc. We also had issues with a fair number of our students come in now and they don't have PCs, they have Macs. And they expect everything to work on their Mac, and they don't recognize that there's still software that doesn't do that. So I had a fair number of students who couldn't make it into the labs, and then their computer couldn't run ArcGIS, so they couldn't even do this at home. So they're having like an extreme problem trying to access this stuff. And then even within the PC users, I have students who have 5- and 6-year-old laptops. They couldn't run Arc either. It would just, they could start to load it, and then their computers would just like sputter and die. It was just sad. They'd get locked just trying to open a file. So the access is a huge issue. I also wanted my students to have access to this after our course. A lot of them may not take another GIS course, but they want to have this on their CV. They want to be able to tell people they know how to do this. And if you've just used it one semester and you never saw the software again, you can list it on your CV, but good luck demonstrating that you know how to use it if you haven't touched it again. And those ArcGIS student licenses are nice, but we only get to get them out for a year, and you have to be enrolled in the class to get one from us, because our facilities department is actually in charge of our Arc server license, not the geography department, and they're a bit stingy. So some of the challenges that I ran into with this, there were quite a few, actually. This was problem 1. Where am I going to find labs? So initially, when I was doing this with ArcGIS as the main software, I was using Getting to Know Arc Desktop, if you've ever seen that textbook. Yeah. So the initial labs, I would let students work through the first few chapters of the book. So I think we probably got to about chapter 4 or 5, just straight through there, using the canned data that's there. And then beyond that, I had a collection of labs that I had written or other grad students had written, some from the internet, some from other instructors. But it was this basic little hodgepodge of labs. And then I realized when I switched over to using Q so that everybody could have it, that I didn't have labs for this anymore. Like, I was going to have to sit down and rewrite every single lab by myself because the other instructor decided that they were just going to teach ArcGIS. So where was I going to find labs? This was a huge problem. I really didn't want to reinvent the wheel. So I actually managed to stumble across QGIStutorials.com. If you guys have seen this is actually pretty cool. They're open source, so you actually can use them in your course. You can put them on your website so long as you do it's a Creative Commons share-alike licenses on them, so you can reuse them. They're really well written. There's the whole community at the bottom of the page where they ask questions, so a lot of the things the students run into are actually already asked at the bottom of the page, so the students get to see that when they're looking at the lab. I started using those in addition to writing a few sort of intro Q labs, like explaining how the layout worked and things like that. My standard lab format is to give students relatively canned data that I know will work and give them a process. The process is written out for them, kind of explaining where to look and things, where are the buttons, what are you going to run into. And then I give them a whole new set of data at the end, and they have to redo the process without specific instructions to that data set. So it's sort of this call and response kind of concept. And I was able to, using the QGIStutorials.com, kind of re-implement that over the course of the semester. Yeah, the faculty. This is who I really expected to put up a wall. When I sent the email asking, I've been assigned my course, and I sent an email to my advisor and to my department head and the other instructor who was teaching, would it be okay if I switched over to Q? And this is why. I was genuinely expecting an email back going, are you out of your mind? And doesn't work, or we can't have classes that are different, or it violates the course catalog. The answer was simply, yeah, sure, whatever. It was like one person emailed me. He didn't sign it or anything. It was just like, yeah, whatever, do it. So part of that is because, again, we're not a huge GIS powerhouse. There wasn't anybody who was substantially invested in ArcGIS in our department. There's not any, well, there is one, he's very close to retirement, one person who's written an Esri-themed textbook. But there isn't anybody else. In fact, my department is highly populated by what are called critical mappers. So people who think of GIS as more than software, that it's a community, it's a practice, it's a way of organizing and thinking about the world. So they're not software adherents either. In fact, they are the people who have come up with this thing. So I didn't realize this was coming when I did my class. So it was 2 years ago that I switched my course over. This is the graduate program they just came up with this past year. This is all open source web mapping. So we use QGIS actually in this new graduate program that we have. So it was part of the reason they were so lenient and so willing to let me try QGIS on the undergrads, was that they wanted to do this as part of the master's program anyway. So I got to be a little bit of a guinea pig. I also got to help write the QGIS course for this. So we have a graduate level QGIS course now. The students. This is actually where I got the biggest kickback. Like, some students came to office hours explicitly to talk me out of making them learn QGIS. A couple of these were people who had a genuine concern. They had seen job descriptions that they liked and knew that those job descriptions asked for ArcGIS and that I wasn't going to teach them that. So I gave them the option that they could switch to the other section if they wanted to. That was fine. The other instructor was teaching ArcGIS. But I made the argument for why they would want to learn QGIS instead. That the course is really not about learning software. The course is about learning how GIS works. That's what an intro to GIS course is supposed to be. You shouldn't be learning where are the buttons in ArcGIS. You should be learning how does this tool work? What is the difference between this tool and that tool? And so I tried to explain to them that, I'm not trying to teach you software. I'm trying to teach you GIS. The software is an extra thing. You can learn it. And I made certain that since we get all those free courses from Esri, those little free things you can sign them up and you get little certificates, yeah, I'd let them have those. I was like, if you really want to do this, if you really want to learn ArcGIS, all of my labs, they will work in ArcGIS. You're welcome to turn them in Arc if you want. So I basically did all the work twice. I did the Arc version and the QGIS version kind of in my head. I didn't publish the Arc version to the students, but I gave Arc help to those who insisted upon learning ArcGIS. And I let them have as many of those little course credits as they wanted. So they could sign up for those, have those on their CV, that they'd pass those little, like the 8-hour Intro to GIS Arc certificate. But most of them were on board with QGIS when I explained to them why they should have it, that they could get to keep it, that they were able to alter it if they wanted to learn how to program. They were on board. So what actually happened? This was really interesting. The first thing that happened, I got better at teaching GIS because I didn't get to rest back on the fact that I knew how the program worked. I hadn't really thought about how, 8 years of working with ArcGIS, that I pretty much had canned answers to people's questions. That I wasn't thinking that much about it. My projections lab is completely different than it used to be when I taught Arc. And in part, that's because Q talks about it in a different way, or QGIS talks about it in a different way. But also, I realized when I was sitting down and just kind of looking at my ArcGIS projections lab and going, oh, damn, this does not translate in any easy way to QGIS. I have to rewrite this complete thing. I realized that even in my non-lab version of teaching projections, I was teaching ARC projections. And there's no reason why you would have to format the way you think about projections into what ArcGIS does in the software. So I had been lazy without realizing it. I'd been upset with the students the previous semester that they were frequently asking me for what I thought was just teaching them to press buttons. And they were, but it was sort of my fault as well as theirs, because that's what I was teaching them to do, was to press buttons. So even when I really thought I was teaching them the fundamentals, I was leaning on ARC. So to switch to a software that I didn't know as well, I mean, I had to learn QGIS the summer before this in order to teach the class, because I really didn't use it. It was really helpful for me to have to learn something and have to make a change. So it was a positive thing. It was more work, but it was positive. The other thing I figured out is that open source actually works really well as a pedagogical tool. I didn't expect a huge change there, but things happened, particularly when I first told the students that there is no help desk. So what has happened in the lab traditionally when there's a problem with ARC that we can't figure out how to fix, we have to go to the lab manager. The lab manager will look at the problem, figure out how to explain it to the help desk tech at Esri. They'll file a ticket. They'll converse with Esri. They maybe get a response. The GIS manager maybe brings it back to the student if they remember, if the student remembers what the hell happened 3 weeks before, you know. And I also recognize that in the fact that we expected to pass the problem off to someone else, that I frequently wouldn't let students really struggle with it. That I knew what the answer to their problem was, that it wasn't going to be something we could solve. We were going to have to call a help desk. So I would just step in and be like, okay, fine, just skip to the next part. I didn't let them have that struggle with the software to figure out for themselves, why doesn't it work? Why won't I be able to fix this? So it helped me to realize I was stopping them from learning by doing that. So that there's not a help desk, I had to actually explain to them how to come up with an answer for themselves. So I had to teach Stack Overflow. So how do you, what are the websites where you can go and have these questions? How do you formulate one of these questions yourself? The students had never had to talk to help desk about QGIS. They'd never had to talk to any help desk. Apps just work. So they had to learn, how do people in this community talk about these problems? How would you say this problem to someone if you want them to help fix it? Because you can't just be like, the button doesn't do the thing. You have to explain, I was trying to clip this layer to this layer, an actual explanation. That was something I hadn't asked students to do for themselves before, and it made a big difference in their learning for them to actually learn how to ask for help the right way. But then they also learned this about software. So in critical mapping, we recognize that software comes from a place, like somebody wrote the thing. So know that there's no help desk. They can't just run off and let somebody else handle the problem. They have to realize that there's a community behind the software and that they're actually interacting with other human beings. So they had to learn to talk to people who had expertise in GIS and explain themselves in a way that people would actually still talk to them. So you couldn't just get on Stack Overflow and ask a total noob question that's there 18 times before you and expect an answer. You needed to recognize the community only wants to answer these questions once. So look in the forums. That someone, when they ask you for more information, they're not being rude to you. They're asking you for more information. You haven't explained your question very well. But they really had to learn to deal with other human beings and sort of recognize that open source software has people behind it and that they could actually be one of these people if they wanted to be. There's this aspect that somebody wrote the software to do something. So not every tool is going to solve every problem you bring to it. So students didn't necessarily recognize that maybe so the one I used frequently was georectification. I have multiple tools for georectification. So we were using MapKnitter, which is an online open source program associated with Public Lab, where you actually just rubber sheet a raster image onto Google Earth. So super simple. You don't need to know anything about GIS. But we would take that, and then we also would do georectification within QGIS, which of course requires you to put down little reference points. You actually have to think about what you're doing. You recognize the software is doing things. But we'd have multiple versions of the same tool to demonstrate that the tools don't work the same way, that somebody could approach the same problem with different answers, and that depending on the way they tried to answer that question within the tool will do different things. It'll work in different ways. So to recognize that people didn't write the tool to solve every single problem. You might need to find a different tool or a tool that works slightly differently in order to get done what you want to have done. And then this was actually the other really big one. Usually the students, they would do their work, they would make their projects, but they never really took like huge ownership of the thing. I had students in the semester that I first started teaching QGIS who traced down like plugins I'd never heard of. There was one student who decided that he wanted to do a time map of IMF contributions to countries that had Ebola. I have no idea why he wanted to do this, but this is what he wanted. So he needed a time mapping plugin. I hadn't used one. He totally understood that like he could talk to the people who built these things. He sent emails to people. I was so shocked. He sent emails to developers, asked them questions when the plugin wasn't very well documented within QGIS. He found blogs that had it. He asked questions of those people. He hunted down the tool that he wanted and used it because he knew that he could go do those things. He didn't need me to step in and find him a tool. I had kids who were doing network analysis who realized that they didn't need me to install, some extra thing onto QGIS for them. They could install the plugins themselves. They could go find the answers to these things. The kids really took ownership of the projects and of actually learning something. I think by taking away the little shiny black box that always does the work and offering them sort of this box of parts that they could see all the guts, that they realized that it was not going to be perfect. It was not always going to work, that it was very much their responsibility to kind of poke at it and get it to do things. And I really encouraged them, when they couldn't make the little box do things, to find other boxes that did them instead. QGIS was mainly what I was teaching, but if they needed to go find another tool that did the thing that QGIS wouldn't do the way they wanted, that they were fully enabled to go out and find other tools. That was totally okay. So next time I do this, which is coming up, I'm going to diversify more. I might bring back ArcGIS a little bit. The students weren't wrong when they said that job applications are asking for ArcGIS. That is true. I mean, until we manage to convince the job market that QGIS is just as capable as ArcGIS, people aren't going to write GIS on their job requirements. They're just going to put ArcGIS. So I probably will bring back a little bit of ArcGIS. I was doing the lab in both directions anyway, so I have the two of them. I think I'm also going to bring in more open source tools. There's so many on the internet, so many plugins and things. A previous colleague had actually introduced R into some of his classes. So there's a couple of R labs that are floating around I think would be helpful just to show students that GIS is actually not the only software in which you can do GIS. It doesn't have to have GIS in the name. You can do spatial work in other places. And this is the big stickler. This is why I think a lot of places will not actually switch to QGIS. There are no textbooks. Nada. I've just seen recently there's some mapping in QGIS ones, but they're about design. A textbook that actually was the Bolstad for QGIS would be awesome, but I haven't found one yet. There is, I think the guy's name is Shelto. He has an awesome textbook, but it's about geospatial technology and not GIS, where he does ARC and QGIS labs inside the book. But it doesn't really work on GIS because he's talking about other things most of the time. So a textbook that actually had QGIS in it would be awesome, because I'm sure not a lot of people really want to put together their own reading lists semester after semester. I think it's kind of fun, but I think if there was a canned way to do this, a QGIS version of getting to know Arc Desktop, people would actually use it. Yeah, so I'm gonna look for some more textbooks and some new things about QGIS. So I would totally be very excited if anyone had recommendations about books to look at, because I need new textbooks. And that's it. So thank you. Questions? Oh, yeah. Ooh, that does not look right. I think my my Google Doc theme did things to that, so sorry about that. But there is an evaluation form. Yay! Yeah.
Spatial SQL.
Uh-huh.
Do you ever do anything with spatial SQL? Because that's one thing that students have no concept.
Yeah.
At least in my experience.
I have not. Asking about spatial SQL and whether we've used that. I haven't really. When I first did the little transformation over to QGIS, I went as basic, simple as possible. There's a whole bunch of things that I've, like running around here, have learned that I'm like, oh, that's coming in there, and we're not going to use the Tiger website anymore. We're totally going to use the API, and I've learned a whole bunch of things actually in the past semesters about what I'm going to bring in. But spatial SQL sounds cool. I should do that. Uh-huh.
It's interesting you say think through the process instead of relying on the buttons, because one of the things that one of the reasons I got the market to do is they can simpler information between anybody to do it, and it's a lot of context. But I wonder, do you ever take a command line? Because one of the things that in the old days, before you had a GUI, what you do is think through what you're doing and the logic and incorporate that into your
I haven't. I really would like to. I did use the R lab that a colleague wrote in the previous semester, and people cried. I mean, there was literally, we don't keep tissue in the GIS lab. We really should.
That was one of the advantages of that, because back when I worked with the DOS database, one of the things I was taught by my mentor was to diagram out what I was going to do before I actually did an interface, because we get lost in all that. You didn't know what you were doing. I was just curious.
No, I want to do that with them. The problem that I have is actually a computer literacy problem. I have to teach people how to open a zip file, which I didn't think would be a thing. But I'm teaching in the state of Kentucky, which does not actually have an elementary, there's no computer science in high schools in Kentucky. There's no required computer science. So the students are really great with apps, and they're comfortable with a computer until you actually show them, what a computer is. And you take away the GUI, and then they freak out. I think they're totally capable of it. I just need to find a way to unveil the computer without frightening them. And I think QGIS could probably do it, though, because they have a little Python console that's in there. So I'm not making them go to some weird, that you could open a terminal within the program. So I think there are ways to do it, and I would like to progress to that, particularly since we're starting to do our advanced GIS course is more and more web map. And the new Maps Plus thing is totally web map. And the students are really interested in that. I think maybe finding ways to do command line in the GIS course would help them understand that they can totally go do the web mapping. But yeah, that's something I want to do. Mm-hmm.
There is a Mastering QGIS textbook. You looked up Packet Publishing?
Yeah. Wait. Oh, hey. Cool. We should talk. Mastering QGIS. Okay, wait. Now I need to write things down. Do I have pens? No, I don't. All right. This is being recorded, though, so I've just said the word 8 times, right?
Here's the...
Oh, thank you. Pen. All right, cool. So, yeah, that's cool. I want to write on here. I have to admit that right before the semester, my look for textbooks was rather cursory for the fact that my the school bookstore forgets to email the graduate students to ask them for their textbook requests. So it was in the, oh yes, this book will have to do. Yeah, but that would be awesome. Mm-hmm.
I have another little bit of shameless plug.
Sure.
Just released today is a book called Discover QGIS through Locate Press.
Mm-hmm.
And this is a workbook for a curriculum I co-authored last year called the Geo Academy, which is a complete 5-course intro to GIS using open source, mostly QGIS and GRASS and Inkscape.
You can get it on Canvas, right?
Yeah.
I was one of your students, yeah.
So the Discover QGIS just got released, and it's in preview mode right now. So Locate Press is giving 50% off this week if you use PLOS4GNA coupon code.
Cool.
And it's in preview mode because we still have a little bit of formatting to do, so you can evaluate it.
Oh, that'd be awesome. Cool. Totally got it written down now. Yeah. I really haven't. So I genuinely had to learn how to use QGIS myself the summer before. I'd used it once for a project. I mean, I learned on ARC. I had access to ARC. I used ARC. But it was the students not having access to it that really was the kicker for me, having to realize I couldn't just rely on that. So I had to learn Q. I haven't messed around much with graphs, but it would probably be something that would be helpful. I mean, because the idea is to teach them GIS, not a particular software. So I did finally learn that there's the graphs toolbox in QGIS. I'm learning. I'm slow.
Did you find a community? Is there a community of like-minded educators who are sharing resources?
There are some people who've managed to swap over, people in other places that were not sort of like serious Esri shops that are doing it. There's a group within Public Lab that are educators who are actually in South America who don't have huge computer resources, so they want things that are lighter, faster, cheaper. And I'm swapping lesson plans with a guy there in that project.
I also make a plug for George Washington University.
Yeah.
They have several classes that do this stuff. They teach OSM as part of their coursework. They teach QGIS and other open source tools as part of their coursework, including PostGIS and SQL. So Nulico and Richmond.
Okay. Yeah, we do actually use OSM all the time. That was the other thing that I switched to using all open data. So I made them go into OpenStreetMap and get their own data. Mm-hmm.
For the previous lecture, the first session after the break is Dr. Natasha. She will be talking about Geo for All initiative.
Which is a worldwide network of academic laboratories that develops the education materials with open source.
Cool.
So I will be talking about it a little bit. So if you are here and would like to join, that would be fantastic.
Cool.
I will be talking about how to join, and if you know about laboratories or schools or universities that are teaching open source GIS and we don't have any knowledge about that, please let me know so that we can contact them and build up the community. We now have over 100 laboratories all over the world, and we would like to increase in the United States. And we will be signing memorandum of understanding with QGIS, so QGIS is also very important.
Cool. All the new things. Awesome. Anybody else? I think we're running. Yeah.
Yeah, I'm curious about your lab setup. I've done the same thing you've done over the past year, and I'm curious how you set it up. Are you just running Q on Windows or using OSGeo?
I had one student who had to use the OSGeo virtual machine because she had a Mac that belongs in the Smithsonian. I found myself, she had the wrong Python version, and I was trying to load Xcode on her computer, and I was like, let me just get you the virtual machine. Everybody else, though, our lab it's a PC lab, and our lab guy installed 2 versions of it because he found 2 versions. Mm-hmm. Cool. Yay, thank you.